Alright, geometry kids, here's your test review walkthrough as promised for your test that's on Monday. Sorry I didn't have this ready for Monday night. It's now Tuesday morning, so hopefully this will be in time for you to get going. We'll do this. This is right out of the book. This is pages 369 to 371. And I just took the scan right out of the book. But I wanted to do that so I could highlight to you what is actually not going to be in our test. We did sections 9.1 through 9.6. We did not do 9.7 and 9.8. There's a 9.7 and 9.8 in the book. They have to do with the lengths of the segments inside the circles. We didn't really do that. And some of like lengths of tangent pieces and lengths of secant pieces and stuff. We didn't do that. We mainly did the angle-y stuff, as you might remember. Okay, but I also thought if I did this stuff from these 3 pages in the book, then there might be a good chance that I actually do some of the things I may would have skipped, like the vocab stuff and the true-false stuff. So this is a sort of a first trial at this kind of idea. We'll see how it goes. And then in class on Wednesday, we'll have some more problems that I make up that are really going to be even more test-like. But this, I think, is a good way to start. Okay, so they tell you that this is circle O, and A, B, and C are on circle O. So just by knowing that, this is called circle O, you know for sure that yes, this is the center. See, I would have forgot to say stuff like that if it was me making up problems. By calling it circle O, yes, this is the center. So you know stuff like, this is a radius, and this is a diameter, and that kind of stuff. And that's good information to know, because I'm guessing that, if we know this is a diameter, we know something very specific about angle C. So, okay, let's see what they ask. AC is called a, all right, first vocab term. Oh, can I type it in there? You know what? It might be better if I just do that. I'll just type that in there. It's called a chord. Okay, it's way too big. Bear with me for a second. If I fix this once, I think it'll always be the same. Alright, so AC is called a chord, and ACC, look at that. See, this looks like the answer key out of the book. This is pretty high-tech and pro. Why don't you, that's great. Okay, and then AC, the line. If I continued the line would be talking about a line that would go actually outside the circle, and that is the definition of secant. Okay, great. That looks pretty good if I do say so myself. Okay, OB, that's what I was talking about before. OB is called a radius. It's hard to type when people are watching you. The best name for AB, the segment, is, what was that? AB, that's this one over here. The best name for AB, well, we'd call that a diameter, wouldn't we? No big surprise there. Okay, coming a little lower than I want, but that's all right. AB is the, okay, we're supposed to circle one of these. ABC, this triangle here, is what kind of triangle in circle O? It's inscribed or circumscribed. A little fancier here. We're going to call that inscribed. It's because it's inside. The thing that is inscribed in the circle will be inside the circle. If it's circumscribed about the circle, it'll be outside the circle. Again, just vocabulary stuff. Line CD intersects circle O in 1 point. CD is called a, wait for it, tangent. That's, again, just definitions of terms. If you didn't know those, you might want to go back and look some of those up, but that's the first one. I guess I should pause on this for a second so you can kind of get your screenshot if you're going to be doing that. I also will print this document to a Word document, I guess, and I'll post that on Blackboard. Okay, next little bit here. This is, you can actually see the page number here. It's page 370. It's the top of 370, and then I split it so I'd have room to work, and I could do multiple pages for this video. Okay, lines ZX and ZY are tangent to circle P. Again, since they call it circle P, we know that that is the center. That's kind of a nice thing to know. Okay, PX if drawn. Well, that doesn't take more than a second. I'll just actually go ahead and draw it. PX if drawn, well, thank you very much. There it is. Would be blank to XZ. XZ is this line over here. What would be going on there if I drew this radius in like I just did? Well, there's a little theorem there that says if you have a tangent and a radius, those things are perpendicular. Okay. Can you actually see that in there? You probably can't. I'm just going to do that here because you can tell that that probably goes in the blank. Okay. If the radius of P is 6, circle P is 6, if I can draw that there, and x to z is 8, then P to Z. Well, this one I actually can find out. Remember I said there's some sections we skipped that all had to do with segments inside circles. This one's actually not too bad. This one we could actually do. Because here, if you look at this real closely, we have a 6, 8 right triangle. Radius, tangent, hypotenuse here. If you did Pythagorean theorem on that, you would find out very quickly that x should be 10. I am not going to do it. I'm going to make you trust me. It's not exactly approximately equal to, it's exactly equal to 10. So PZ would be 10. Okay. If measure of angle Z is 90, ooh, that's interesting. And this other stuff now I can forget about. If measure of angle Z is 90, wow, maybe I should get rid of this too. Okay. Measure of angle Z is 90. Well, that'd be weird. And X to Z is 13. Then how long is it from X to Y? Well, that's kind of a silly one. That's the ice cream cone thing. I know that this segment here is congruent to this segment here. If there's a tangent, as a point outside that's got a tangent drawn to two different places on the circle, that thing has to be the ice cream cone, meaning it's like an isosceles triangle kind of thing out there. Okay, if XPY is 100, XPY is 100, let me go back and erase some of the junk then. I think they keep making up totally new situations. XPY, sorry, this would be a different color if I can stop right-clicking. If that's 100 degrees, and be careful, I think it's a good idea always to mark degrees as degrees and things that are not degrees with not degrees, because people are mixing up, especially when we start getting into arc measure, they're mixing up length and degrees, and they're completely different types of measurements. Okay, if that angle is 100, then the measure of arc xy, well, that's just the definition of arc measure. That's like saying x to y around the circle is 100 degrees of circle. If this central angle is 100 degrees, that's what that means. Again, people got confused with that, wanting to call one of these things 50 if one of them's 100. That is not what's going on here. This is just the simple version. This is just like Pac-Man. Oh, can you see Pac-Man? The degree of his mouth is the same as the degree of the mouth opening, and that's it. It starts to get double and half and weird stuff when the vertex is somewhere like W or on the circle. Okay, if the arc from X to W, again, they keep changing their mind about what the measurements of these circles are. If the measurement of arc XW is 135, so if this is a 135 degree arc, again, that'd be like saying that angle at P here would be 135, WPX would be 135. And the arc from W to Y, this arc is 125. Then what's the arc from X to W to Y? X to W to Y. Well, you can just add these things because they both sort of have an endpoint at W. You can add 135 plus, I'm glad I have this workspace now, 125, and you get, oh, watch me do this wrong, 260, hopefully, 260 degrees. And if XW is, this is arc, be careful, this is arc XW is congruent to arc WY, well, wasn't a second ago. Let's change this again for the next problem. If these arcs are congruent, and you don't really mark them with a tick mark, but I guess you can. Actually, I don't know if that's defined. I can't remember if the book does that or not. It doesn't bother me. I'm going to go ahead and do it. If those arcs are congruent, then again, this is just for my own little notes right now. It's not really technical. If XW is congruent to WY, then the measure of, sorry, then XPW, this angle here, is congruent to what other angle? Well, if this arc is congruent to this arc, then the central angle it makes, like whatever this measurement is in degrees would be the measurement of this arc, would be congruent to this arc, and this angle's measurement would be the same sort of thing. So it would have to be congruent to that angle, which would be angle WPY. Okay, pause for effect, and we're going to keep going. Okay, so we're still on the same page here. Number 12. And by the way, as I go through this, another major thing I'll be doing, and it looks like it might be coming up, is crossing out the parts that are in this chapter review that aren't going to be on the test. Things like proof and things like, especially, those sections we didn't cover. Okay, they tell us this, and I can probably believe this for the whole group of problems here now, that in circle X, so that's good news, X is the center, the measure of arc AC is 120. That's kind of hard to mark, but if I color this in, and say that's 120 degrees. That's going to be nice. Okay, and that's not just AB. That's all the way from A to C. Okay, So the measure from A to B would be what then? Well, if this is perpendicular, I know all kinds of nice things about point E and this situation here. That first of all, E would have to be the midpoint of AC. XB kind of bisects AC in lots of ways. It bisects the segment AB, it bisects the chord AC, it bisects the angle at X from A to C. Everybody's symmetrical and happy and all that kind of stuff. So that 120 is kind of in my way. Really all that it tells me is what I'm about to answer here. Which is a little nicer to say even, that this is 60, and that's kind of out of the way now of this one, which is also 60, and that is that. These are 60. Okay, if AC, if the chord AC, now you got to be careful about these little notations. This is an arc, this is a chord. If the chord AC is congruent to the chord AD, so this thing is congruent to this thing, then the measure of CD now would have to be the same as AC. That marks a, that makes a congruent arc here and here. So this would be equal to the measure of arc AB. I bet they mean, sorry, AC. I bet they actually want us to say that's 120. From A to C is already 120, so from D to C is also 120. I don't know if they want this or this for that answer, but either one is true. If the distance from X to E, unless there's nothing on top, that means the distance, nothing but an angle or anything like that. If that's actually 5 and A to C is 24, well, I'm actually just going to do this. Then each part have to be 12. Then the radius is what? Well, the radius would be like X to B. All right, I'm gonna redraw this a little bit differently. Let's draw triangle X, and this should start to look familiar. This is happening all over this chapter. Pythagorean theorem. We've got all kinds of perpendicular stuff, all kinds of diagonally stuff. I know this is 5. I know this is 12. I'm looking for any radius of the circle. What's nice about finding the radius of the circle is you can draw the radius of the circle kind of wherever you want. I could try to find XB. If that didn't seem kind of very easy, I could try to find XA. If that wasn't nice with the measurements I was given, I could find XD or XC. But this way, the way I drew it here, I think XA is a good way to do that. And of course, they tell us that E is a right angle. So all I have to do again is Pythagorean theorem. Shouldn't feel like a big surprise. And actually, these are nice numbers again, kind of like the last one that the book made you do with the 6 and the 8. This turns out to be exactly 13. Again, I'll let you do the fun part of the calculation if you don't believe me. All right, if AC equals DC, hard rock joke right there. There should be a lightning bolt here. All right, state the theorem that allows you to deduce that XE is congruent to XF. All right, AC, pause. Someone just walked in my room. All right, I don't know if you heard that or not, but yes, one of your geometry student comrades barged in right there in the middle of my video. First time that's ever happened. That's kind of cool. All right, AC/DC was the thing going on there. State the theorem that says, you know, that the distance from X to E is the distance from X to F. You know what? I don't think I'm ever going to make you do that on the test. The thing to remember here, as you go through these and you find review problems or whatever, is just basically remember, though, that this implies that those things are congruent. Okay, I'm almost out of time from this video. I'll have to go on to part 2 next. I will see you there.